Hello, calculus students, and welcome to another online lesson. With today's lesson, we'll be continuing our discussion from the last video involving correlation, specifically the correlation coefficient, as well as best fit lines we'll be talking about today. This is our second video on correlation, and it's also our last video on correlation, so it's just a two-video unit. Our goal today is to be able to use the calculator to find the line of regression. We'll talk about that, what that is, as well as from last class, our correlation coefficient. And then we also want to be able to comment on the reasonableness of predictions or estimates made using a regression line. Last class we talked about the correlation coefficient, and this is just a review of different values that you can have for R. If R is close to 0, your correlation coefficient is close to 0. In fact, if it's anything less than 0.5, we say that's a low or weak correlation. If the absolute value of R is anything above 0.87, meaning like if you think of it as a percentage, like a B plus and beyond, we have strong or high correlation. And then whatever is in between there, the 0.5 through 0.87, is our moderate correlation, though that will occur less likely on an IB exam. Usually it's really good or it's really bad. And just a reminder that R can also be positive or negative, and we want to include that when describing our correlation as well. So why do we care about correlation? Well, we can then, we're going to talk about best fit lines today, and that'll be our next slide. But if we have a best fit line with a poor R value, meaning that the absolute value of R is less than 0.5, so it's a weak correlation, that best fit line does not represent the data very well. And if we use that line to make any predictions or estimates, they are said to be unreliable. So there's only two ways that we, for this course anyway, that we're concerned about our data being unreliable. Number one is if we have a bad correlation coefficient, meaning an R value whose absolute value is less than 0.5, less than half. And there's another way that we can have a bad prediction, and that's if the data being predicted is outside of, or the data being used for our prediction is outside the given data range. And we'll look at an example of that coming up. Now, best fit. You've probably done best fit lines in other classes as well. If you have a scatter plot, you can draw a line that sort of resembles the trend of our data. When creating a best fit line by eye, like what I just did, where I didn't use a formula or anything like that, we want to use what's known as the mean value, or sometimes referred to, especially by IB, as the mean distribution. The mean distribution is if you take all your x-coordinates, or the x-coordinates of your points, and find the mean of that, and then take all your y-coordinates from your points, find the mean of those values, and put that together as an ordered pair. That's the mean of the distribution, or the mean value. And you want to plot that point and make sure that your best fit line goes through that point. Most likely, we'll be creating our best fit lines using an actual equation. And one type of best fit line is called the line of regression. We will be getting that using our calculator, but there is a formula for it. It's right here. And that formula is based heavily on point-slope form, where the point that they're using is the mean of x and the mean of y, and then the slope that they're using is derived from the covariance and the standard deviation of your x value squared. Again, we won't have to do that by hand, but that's where this formula comes from, so we could do it by hand. This formula is also sometimes referred to as the least squares formula. The old IB test used to sometimes call it the least squares formula, but these days it's pretty commonly referred to as the line of regression, which is a type of best fit. So if they ask for the best fit line, again, they're meaning the line of regression. Again, it does go through the mean value, and what else should I say about that? Not too much. And again, we'll be using this to make some predictions. Yes, the last thing I'd say is that you'll be using technology to get that, and I will show you how to use that technology coming up right here. So here we've got an old IB question here. At the end of a year, only 7 of our female science students sat in examinations for science and French. So we're talking about IB students who are taking both science and French tests. The marks for these 7 students are shown in the following table. So they give all of the science scores as well as the French scores for these 7 female students. Using your graphic display calculator to find the correlation coefficient, or R, for the above data. Well, that's what we did last class. So let me pull up my calculator. Okay, and the first thing we need to do is get our data into the calculator. And to do that, we go to Stat and Edit, just as we've been doing for the last several units. And I've already put my numbers in. It's important to make sure that we have the same amount of data in each one. Clear your lists ahead of time. That way you won't accidentally have old data that's messing up your calculations. And those are the numbers if you want to plug them in yourself now. Once we've got that in, we go to Stat, we go to Calculate, and we go to 4, Line Reg, which stands for Line of Regression, which we just talked about on the last slide. We're going to do L1, comma L2. In the last video, I told you that you needed to have your diagnostics on. If you haven't done that yet, press second 0, scroll down to diagnostics on, and press enter twice. But otherwise, you don't have to do that if you've already done it once. I hit enter, and I get some values here. The one that we were asked about is the correlation coefficient, the R value. And I see that right here. So our R value is negative 0.989. How would we describe the correlation then? Well, based on our chart, again, the absolute value of R is very close to 1. It's well above 0.87, so we would say this is strong or very strong correlation. But we also need to use a word describing the positive or negative aspect of it, and we have a negative sign here. So this is very strong negative correlation, meaning as the science scores go up, the French scores are going down, and vice versa. So use your graphic display calculator now to find the equation of the line of regression for this. Well, we already have it. It's right here in front of us. Line reg, same screen. And a line is just using this form, which is y equals, we usually call it mx plus b, m standing for slope, but here they just use the traditional way, which is ax plus b. Again, you got a first, you have b second, and those are the two numbers that aren't your x or your y variable. Obviously, the a is the coefficient of x, and that would be our slope, and the b is your y-intercept. Well, they actually gave us values here of a and b, so all we have to do is write those down. So our equation for the line of regression is going to be y equals, and then I'm going to take this a value, which is approximately negative 0.619. Again, this value right here, I rounded that to 3 significant figures, and then x comes after that, because I'm writing the equation of a line, plus b, which is 78.2. All right, then it goes on to say that Carletta's mark on the science examination was 4. She did not sit for the French exam. Estimate Carletta's mark for the French exam. So we're saying we're going to use this data that we have here, or specifically this line, or equation of a line, to make a prediction about Carletta's French exam, even though she didn't take it. She took the science exam, it was a 44. So 44 being science, that was our S variable here, which we put in first, which is technically our X. And I guess actually I should maybe go back to that last part. I used X's and Y's because that's what I'm used to using for a line, but those aren't the variables they gave us. They gave us S and F. S being like our X value, it was our first set of data. So really I should probably have an S here, and then I should have an F there. I wouldn't mark it wrong if you put X and Y, but that's really what we have. And that helps us out here now on our next problem, because we're estimating the French exam. So that's what we're trying to find, but we already know her science exam number. So we're going to rewrite this equation as F equals negative 0.619, and then instead of writing S, I will actually put down the score that she got on her science, which was 44 plus 78.2. So it's kind of like we're back in Algebra 1 or Algebra 2, where maybe even pre-algebra on this one, where we're just plugging numbers into our linear equation. So we can go ahead and throw that into a calculator here. I won't erase my screen so that we can leave everything up. And we end up getting, and you can do this in one step here. You don't need to first multiply and then add because your calculator knows order of operations. And I get 50 point, well, about 51 if I round. It comes out to be exactly 50.964. So the question is, can I write that down? Can I just say, well, it's an exact answer. That's what my calculator gave me, so can I just write that answer down? Well, it's not an exact answer, and the reason it's not is because we're using this number and this number, which were rounded. So since we're using rounded values, we technically have a rounded answer. So I am going to make that 3 significance. We are going to round the 9 up to 10, carry the 1, so we have 51.0 would be her French score. Okay, then we go on to part D. Monique's mark on the science exam was 85. She did not sit for the French examination either. Her French teacher wants to use the regression line to estimate Monique's mark. For part D, they're not actually asking us to do the math. It says state whether the mark obtained from the regression line for Monique's French examination is reliable. Justify your answer, meaning explain your answer using words. So, Monique had an exam score of 85 for science, and we're going to plug that in for our S, or we would plug that in for S, and then find F, just like we did for Carletta's mark. Would that give us a reliable answer? Well, if you look at the actual data that we had here, the highest science score we had was these up here in the 70s. Monique's is way beyond that, 85. And so since it's outside the range, we can't use that as a predictor for other values. Think of it this way. I think I used the example of running a race. Again, if I run a 4-mile race, I can't use that as a predictor for a marathon because I haven't trained for a marathon and that data wouldn't hold up. Or our bell ringer for next class, we're going to talk about a program where students will take it, and age affects how long it takes to do the program. Older students learn a little bit slower. Younger students learn a little bit faster, and that would be true for the given data. But if you go to a really young student, like my son, for example, who's only 1 year old at the recording of this video, he would not be able to learn faster because he can't read yet and things like that. So you have to always work within your given data range. 85 is outside of the data range, so obviously Monique is a special science student. She got a very high score, and maybe that would also make her better at French as well, or something like that. And so we could make an estimate, but we don't know whether it's reliable or not because it's outside the range. The only other reason that we wouldn't like Monique's prediction is if our R value is poor. But our R value is great. Even though it's negative, it's very strong negative correlation. And so that's not the problem. The problem is that the 85 is outside of the data range. So it's not reliable, and the reason is because 85 is outside of the data range. All right, so we have a few problems for you in the book. On page 558, 3 to 4, 560, 3 to 6. All of these questions, or almost all of them, ask you to draw a scatter plot, and you don't need to do that. You can follow my steps and actually just do it on the calculator like I did last class. And actually, while I've got it here, I may as well give you a quick refresher on that. So our line of best fit that we had for that French exam, we can actually type that into our calculator using our y equals mx plus b formula. We had our slope again was negative 0.619, and our y-intercept was 78.2. So I'm going to go to y equals, and I'm going to actually type in negative 0.619, and that was like my x, or my science score, plus my y-intercept, 78.2 approximately. And then I've already got the data put in the calculator still. If I go to second y equals now, I can turn my stat plot on. I want to make sure that the scatter plot is selected, which is the first option there. It automatically defaulted to L1, L2, which is where my data is, and I can go ahead and graph, but I should probably adjust the window first. I know that we had scores that I'll go start at 0, and I think our scores were going all the way to, well, I'll go to 100. I know they didn't get quite that high. And then I'll go to a scale of 5 for my x, and then for my y, I'll go from 0 to 100 again, because that seemed like the highest possible score, even though most of ours stopped below that. And then we'll do a scale of 5 for the y, and then graph. So now you can see both my best fit line as well as my points. Remember, our correlation was strong negative, and we can see that all of the points that we have here, the 7 test scores, it appears that they're right on the line or right next to the line. And they're following a negative trend, meaning as the, again, X was the science, so as the science scores got higher, the French scores got lower. So here we have someone with a high science but a low French. Here the people with the high French scores had low science scores. And so that's why it's negative correlation. And that's a way that we can sort of check and see the data, see our best fit line, see how it's all fitting together. And so we're not just using the R value blindly. Though, if your correction or your data is correct, then those values of R should tell you about the graph without even seeing it. Okay, so we'll finish with that, and we will see you next time.